All right, perfect. Okay. All right. So one thing before we get started. So there was a little bit of miscommunication. You know how it goes with trying to get you guys materials and all that stuff. Okay. So I had intended on you guys having an extra mason jar for today. Okay. And you do not, right? You only have one mason jar that's being used for your rock candy. Yes. Okay. All right. Do not pour that out because I want the rock candy to keep going over time. We're trying to make it pretty large. Okay. So that kind of poses a problem for today because I needed you guys to have another mason jar and you don't, but that's okay. Not a big deal. So what we're going to do today is kind of talk about like the plans, talk about the project that we were going to make today. I'm going to go ahead and do it on my end and let you guys see it. And then you will have your other mason jar. Like some of you are getting it delivered today. Some of you are getting it delivered, I think tomorrow, whatever the delivery schedule is. But anyway, you're going to have that mason jar by Thursday. So pretty much on Thursday, you guys are going to make 2 projects for me instead of doing one today, one Thursday. Okay. But it's still going to work out the same. It's fine. You know, not a big deal. We'll just kind of make both on Thursday. So today, you know, I don't expect class to take too long because you guys aren't going to be producing it with me. I do want to go ahead and talk about the science behind it and give you an idea of what you're making. But like I said, you won't actually be able to make the product today. We're just gonna double up and do both on Thursday. Sound like a plan? See, I knew you'd be flexible. I knew it wouldn't be a big deal. Miss Amy was like, oh my gosh. I'm like, it's fine. It's not a big deal. Kids are great. We'll make it work. Okay. All right. So I want to first go into the Google Classroom. Let me start sharing my screen. I want to share this one and share. Okay. So what I want you to notice, again, last week, if you weren't in class, so last week we did the first project that we started off with, which was rock candy. Okay, so with rock candy, you guys are producing your own rock candy, you know, that you can go to probably most commonly Cracker Barrel. You can go to Cracker Barrel and purchase it, but you guys are making your own. Okay. So yeah, last week in class, we did rock candy. Now, again, we'll probably let this grow for about a week, maybe a week and a half. As we're letting it grow, again, the assignments I have for you guys, I want you guys like showing me pictures. I want to see what you guys are doing. Okay. So, you should have already posted your picture from day 1. So for you guys, that would have been Thursday of last week. You're my Thursday guys, okay? Or my Monday, Thursday. Yeah, that's right. So I'm wanting to see your picture when you got it done. Now, the second thing I would like for you to do either sometime today, sometime tomorrow. I've already had some people turn it in, which is awesome. But I want you to take a new picture of your rock candy sometime today or tomorrow and get that uploaded for me. Okay. So this is roughly about day 4. You know, and if you made it a day later, then maybe it's only day 3, but you know, I just want to see a couple of pictures of progression. So here, I took a picture of my day 4 earlier. So you can see these crystals are starting to grow. Okay. So again, we started out with the sugar on that skewer in order to get the crystals to start growing. This was their seed. So after 4 days of sitting in the solution, we've got some crystals growing. Now you'll also notice too in your mason jar, like I've got a lot of crystallization here on top. Remember too, to keep that skewer suspended. So you don't want it touching the edges. And you don't want it touching the bottom of the mason jar because it'll get stuck and you won't be able to get it out. Okay. So like I said, I would like for you at some point today today or tomorrow, but take a picture of your rock candy so I can take a look at it and see how it's going. Okay. And again, that's here in the classroom under Rock Candy Day 4 progress picture.
Miss Shelley.
Mm-hmm.
So I put it away and didn't look at it or touch it.
Yeah.
And my stick ended up moving. So my stick is literally stuck to the side of my mason jar.
Oh, is it stuck?
Yeah.
Have you tried to get it off at all?
No, but I made a second one, so I'm gonna look at it after this meeting.
Oh, okay. Okay, good. Well, perfect. I know. And it's amazing how like stuck it can get. My second mason jar ended up sliding and getting on the side. I couldn't get it out either.
Okay.
That's all right. Hey, again, this is science. Like there's no right or wrong here. We're just having a good time. Okay. All right. So rock candy, take care of that at some point. All right, so if you look today, this morning I posted our new project, which is going to be a lava lamp. So like I said, I intended on, let me go ahead and pull up, let me share my other screen. I want to share my OneNote. Let's just do it like this. And then I'll pull you guys over here. I'm actually in my office today, so I can have 2 screens instead of having to be in my kitchen. Okay. All right. So can you guys see the lava lamp lab? Okay. All right. So like I said, a little bit of miscommunication. So you don't have a second mason jar today. And I intended on you having that second mason jar, but it's like I said, it's not a big deal. We're going to talk about the project today. And I'm going to actually demonstrate one. I'm going to go ahead and make mine and let you guys see it. And then on Thursday, you guys will have the supplies that you need. And so you'll just make 2 projects on Thursday instead of 1 today, 1 Thursday. Okay. So you'll just kind of double up. So you're still getting to make it and all that good stuff. It's just those of you that like to do it one-on-one, hands-on with me, you're not going to be able to do that today, but we'll take care of it Thursday. Okay. All right. So today we're going to be looking at lava lamps. So there's a couple different science topics that I want to kind of talk about and pull into. We're going to talk about polarity. We're going to talk about density, and we're going to talk about chemical reactions. Okay. Again, I know that some of you have had chemistry, some of you haven't. Honestly, it's all science levels. It doesn't make a bit of difference where you're at high school wise on your science background. Okay. So materials needed for this, you're going to need a mason jar. Now this time we are actually going to use our mason jar lid. We didn't use it for the rock candy. So when you get your mason jar, either today or tomorrow, whenever your delivery comes, be sure to keep that lid this time. Okay. So you're going to need a mason jar. You're also going to need some water, and I'll talk about how much here in a little bit. Also in your delivery, you should have some vegetable oil or getting vegetable oil. I think you have all the materials except for the mason jar. Is that correct? Okay. All right. That's what I thought. So you've got your vegetable oil. You've also got your food coloring. So probably the same food coloring that you used with your rock candy. And then you may have some glitter too. Glitter is completely optional. Some of you may be all about the glitter, and some of you say, ooh, I hate glitter. I'm not using glitter. Completely optional. And then the last thing you're going to need today are Alka-Seltzer tablets. So you should have those too. Okay. Now, again, today I'm just going to kind of demonstrate it for you. And then on Thursday, we will take class time and build it together. Okay. All right. So first things first, I want to kind of have a little bit of a pre-lab discussion like I like to do before every project. Because again, these projects are fun, but I want to talk about the science behind it. Like, why the heck is it working? Why is it doing what it's doing? All of that good stuff. Okay. All right. So I've got let me stop sharing so you can see my camera. Got my camera on. All right. Beautiful. So I've got a true lava lamp turned on here, and I've had it on for a couple hours. And so as you can see, what happens is if you have a lava lamp or have ever taken it apart, so it's a sealed container. Now, one misconception is inside this lava lamp, it's not actually water, it's a different type of solution. Okay. But once you turn the lava lamp on, it has a lamp down here in the bottom. And so the lamp heats up, which this one happens to be like a pinky reddish purple color. But you can see, I don't really have a technical term for this other than like blobs. Okay. But the blobs of the lava lamp start moving. And so you can kind of see this circulating motion happening. So as the blobs heat up, you'll see that they start to slowly rise to the top. And then once some of the blobs get up here at the top, then you'll see like this one here is starting to come back down. And so you've got this continuous motion of up, down, up, down, up, down. And so what I want to talk about today first is, okay, well, what is happening? What is the science behind this? Why do I have things coming up, coming down? What makes a lava lamp work? Okay, so we're going to kind of talk a little bit about the whys today. And then, like I said, on Thursday, you guys will produce your own and you'll see mine today. And I want to kind of have a discussion on why it happens. Okay. All right. So let me pull that lab back up here. Uh-oh. Hey, Miss Amy, do you mind to make me the host again?
Yes, I tried to sign in not as me. And that obviously didn't work. Is your recording still recording?
Yeah, it seems to be. It's got a, okay. Yeah, it's still recording.
Okay, good. That was what I was afraid would happen, is that.
Yeah, no, it's still going.
Okay. Well, that's good to know. I was afraid that if I came back in as myself, that your recording would stop. Hey, everybody, it's good to see you. Ames 126711, who are you?
Let's see if I can get an answer. I have to unmute. I don't know. Anybody know? Ames 126711. Let me message.
How will we know who you are if you don't change your name?
Direct message. I don't have anything yet. Okay, while we're waiting, I'll go ahead and get back to my lab here.
Well, hang on a second. So,
oh, sorry.
I apologize because I was supposed to have you make sure you had 2 jars, and I didn't do that. So that's my bad. So sorry. Now I'm shutting up.
Oh, they're trying to change it. That's okay. It's Jennifer. All right, hold on, guys. I'm almost done. All right, thanks, Jennifer. Okay. All right, so let's pull the lab back up. And let me pull you guys back over here so I can keep watching you. Okay. All right. So first thing I want to do is talk about, again, kind of why we see that action of up, down, up, down, up, down. So let me get where I can write. All right. So after watching the lava lamp in action, we're going to discuss how it works. So there's two different concepts or two different discussions that I want to have. All right. So the first one is a discussion about density. So I am curious, does anyone know you could either tell me the formula for density, you could tell me about like what two things I have to have in order to know the density. Have any of you talked about density yet in one of your science classes? I'm just curious. Do you know what, if you do you know what things or what variables I have to have in order to calculate a density? Anybody know that?
Is it volume?
Okay, volume's one of it. Love it. Do you know the other?
Speed?
Yeah, so volume will be represented with a V. Do you know the other one that goes in there with it?
Is it mass?
It is mass. Great. So when we find density of a substance, it's always mass divided by volume. So it's when I talk about the mass, oh, and of course you guys are chatting me and I'm doing it. Yep, you had it. All right. So when I have the mass, I'm talking about how much stuff is actually there. Okay. And then the volume, when I have that volume discussion, that is talking about how much space it takes up. So density is calculated by taking my mass divided by my volume. All right, so I want you to think about that lava lamp. So what happens as this lava lamp is running, when I turn it on, essentially what I'm doing is heating the blobs. And so we're using a real technical term here, but we're talking about the blobs, okay? So when I turn on that light bulb, what happens is that now this, and let me turn on, hold on, I got about 15 different cameras here. Let's get this back on. Is the camera back on? My camera? Nope, it's not. Oh, come on. Hold on, guys. Well, let me try one more thing. Okay, well, that's fine. That's not a big deal. Oh, well, there it goes. Yay. Okay. Failed to start video camera. I'm telling you, this document camera in my, nope. Okay, that's fine. You don't want to work. That's fine. I'll try one more time.
I'm sorry you're having so much trouble with that camera.
That's okay.
Mine.
Yeah, it's just it just does not want to work for me. Oh wait, hold on. Maybe this will pull it up. Hold on, guys. Nope. Okay. All right. Scratch it. We'll come back to it. All right. So back where I was talking about our density discussion. All right. So what happens is as we turn this light bulb on, it starts to heat up those blobs. So there's actually a little saying I like to use called heat them up, speed them up. So think about it in terms of particles. So what happens is when we have this light bulb on, we are making those particles move when we heat them up. And we talked about this last week as we were heating up our super saturated solution for our rock candy. So remember, we had the water boiling, and that boiling water helped heat up those sugar molecules and got them moving faster and faster. So that's exactly what's happening inside this lava lamp. So when I heat up my blobs, now they are being heated and they're moving around more and more. So kind of think about this relationship mathematically. So what I am doing as they are being heated and they are moving, I am increasing the volume or increasing the size of those blobs. So when that happens, as they are moving around more and more and more, let me get my camera back on for you. So as these blobs are moving more and more, so they're heating up, they are expanding, so that volume is getting bigger. Well, think about that mathematically if I were to look at this as a fraction form. So if I have D is equal to M over V. So tell me about what happens when I have my denominator here and I increase the size of the denominator. What happens to that value of that density if I divide by a larger number? Tell me about what happens. Don't be afraid. Are you guys chatting me? You're probably chatting. So if I were to divide by a larger number here, let's look at an example. Let's say I divide by 1 versus dividing by 2. What happens to this number here in the examples? Let me see what you got. Oh, good. I'm glad. So what happens to the value of D as I change from 1 to 2? What do you guys think? Don't be shy. Take a guess. Got to chat. Okay. All right. So as I divide by a larger number, when you have a larger denominator, this value actually gets smaller. Okay. So think about what that means in terms of this lava lamp. As this lava lamp heats up and the volume gets larger, then my density here gets smaller. So what happens is it becomes less and less dense. Well, that's why I see my blobs start to go up to the top. Well, then once they reach the top of the lava lamp, now they're not sitting on top of the light bulb anymore, and they start to cool down. So just the opposite happens. As it cools down, well, now my blobs get colder and they start to sink back down to the bottom of the lava lamp. Hold on, let me grab something else, see if I can get my camera on. Do it this way. Okay, I'll just hold it. Not a big deal. Okay. All right. So again, as this heats up, my volume is getting greater. It is rising to the top. Now you see this blob start to move back down. That's because he's cooling down and going to the bottom. Okay. So density is a huge factor on why this lava lamp is in action. Okay. Now, the second concept that I want to talk about is polarity or someone's attraction. Okay. So again, we're going to keep it real basic. We're not going to go in a whole lot of details, but when you hear that term polarity, I just kind of want you to think about it as a description of attraction between molecules. So the first question you may have, or a big question that I like to ask when I look at lava lamps is, okay, so inside this lava lamp, there are clearly two different substances. You've got kind of this pinkish color blob along with this purplish color liquid. Well, why do they stay separated? Why is it because even if I were to take this off and like give it a really good shake, it is still not going to mix together. So why in the world, when these are both in the same container, why aren't they mixing? Why are they being two separate substances? Okay, so a good way to talk about this is in terms of polarity or the attraction between those molecules. So what happens is that these blobs are actually more attracted to one another than they are the purple solution or the purple liquid that they're floating around in. So the reason they don't come together and the reason they don't mix is because of that attraction. So this purple blob is more attracted to one another and forms that shape instead of being attracted to this purple syrup or purple liquid and actually dissolving. Okay, so both of those concepts, both density and both polarity, we're going to look at today as we make our own lava lamp. Okay. All right. So since my document camera is being a little finicky, I'm going to set up my laptop so that you guys can just see me do it this way. All right. So like I said, you guys are going to see me, I think that should work. You guys are going to see me build it today. And then on Thursday, when you guys come back to class, we will actually, you guys will you'll just have two projects on Thursday. Okay. All right. So step one of my procedure, I need my clean mason jar. And again, you will need both the jar and the lid, okay? All right, so got my mason jar. Step 2 says to fill the mason jar about 1/4 of the way full with water. So on your mason jar, you've got it measured. If you look over here on the cups and ounces size, when you guys fill it up, I'm gonna have you fill it up to 8 ounces full of water. So I'll go ahead and do that. Oops. And it doesn't have to be exact, pretty close. Okay. Now we're going to take some vegetable oil and pour it in about 3/4 full. So you don't want to go all the way to the top. We're going to actually stop here at 24 ounces. So kind of where the jar starts to narrow. I'm going to pour my oil in. All right, so, and you guys have seen oil and water before. You know that they don't mix. So again, this is that discussion of polarity and density, really. So the reason the two solutions do not mix is because the water is more attracted to itself than the oil. And vice versa, the oil is more attracted to itself than the water. So that's how we form these two separate layers. Now, the reason they layer like this is because of those densities. So the reason that the water is setting below the oil is because the density of the water, it is actually more dense than oil. So it sinks down to the bottom. Okay, so we have our two layers separated. Now, you could just leave your lava lamp here, but to me, well, that's not very fun. I like a little bit of color, okay? So what we're gonna do is add some food coloring to it. So you wanna add about 8 to 10 drops of food coloring. So I'm just gonna add one single color. I'm just gonna add purple. Now I want you, let me get kind of close here. And actually I'm gonna stop sharing my screen. So that way you're right here on the camera. And let me go to speaker view. Okay, perfect. And okay. All right, so we're gonna add about 8 to 10 drops of food coloring. Now, I want you to watch to see what happens to that food coloring after it's sitting here for a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so if you notice, our food coloring is kind of forming the same blobs that we saw with the lava lamp. Now, I want to just kind of leave it sitting here for a minute, and I want you to watch what happens to the food coloring. And all right, so you see that? You see how it kind of exploded? All right, so I think that is so cool to watch. And actually, see, there goes another one. And actually, we're going to do a little bit more with this concept next week. So I don't really want to talk about the science on why this is happening. It's just something I wanted you to notice, okay? All right, so I've added some food coloring. Here goes another one. It's starting to mix through. Now I'm actually going to add glitter too, because I don't know who doesn't love a little bit of glitter in their life. So we'll add some glitter. You know, there's not really a rhyme or reason, just kind of put some in there. All right, so I've got my oil, my water, my food coloring, and then you can see the glitter as I move it around a little bit. You can see the glitter up here, okay? All right, so now if I were to leave my solution like this, well, that's not very fun, right? That's like having our lava lamp just turned off. So we want to quote unquote turn it on. Well, we're not going to heat it up. What we're actually going to do is use Alka-Seltzer tablets to get it done. And again, it is all about getting those molecules moving. So I'm going to take a couple Alka-Seltzer tablets and go ahead and add it to it. Now, I want you guys just to watch it at first, and then after it gets close to being done, then we're going to talk about why, okay? So I've got my tablets. I have 2. I'm going to kind of break them up into halves and drop them in, and then just let you guys watch, okay? And then I'm also going to put the lid on. All right, so there we go. You guys can see that. We're going to watch it for just a minute. All right, so you can see your blobs moving around. Now we're going even faster. Even more, still got, if you can see in there, still got lots and lots of blobs. Okay, Alka-Seltzer tablet is about dissolved, it looks like. Now, if you listen, I don't know if you can hear that or not. Again, you'll make this on Thursday, so you'll be able to see it. But if you listen, you can kind of hear that sizzling, that noise, okay? So what happened, that noise, is actually why our, let me switch my camera around, is why the lava lamp was was moving. Okay. So as we added those Alka-Seltzer tablets, we actually produced carbon dioxide gas inside this container. So again, lava lamps move, or lava lamps work because of the movement of molecules. So what happened is, as we put those Alka-Seltzer tablets in there, the molecules, the gas started to form. And so the gas got all of these molecules to start moving. So as they are moving, that's what we had, that up-down rotation motion, just like we do with the lava lamp. Now, if you compared the speed of this lava lamp compared to the one that I started with, the traditional lava lamp, obviously this one moved a lot faster than the other. And again, that's because we produced a gas. So gas particles are crazy. I call them like the ADHD particles of chemistry. So gases are constantly moving. They cannot sit still. They're always active. So inside here, all of these gas particles start moving around, and that's what gets that rotation of that lava lamp going faster and faster and faster and faster and faster. Okay. All right. So, like I said, I know that you guys just kind of had to watch me demonstrate it today. But on Thursday, you guys will actually produce it on your own. Okay. Now, if you look here, I've got on your assignment, you know that we kind of always have like a post-lab discussion. So I don't actually, let me start sharing my screen again. I don't actually want to talk about these questions until you guys build your own lava lamp. Okay. So if you want to go ahead and look at them between today and Thursday, then you are more than welcome to. But I don't actually want to get really into this discussion until I see you guys making it with me. Okay. Now, another thing too, the assignment that dropped that goes along with it is the lava lamp video. So again, you guys are more than welcome to make this lava lamp on your own time once you have all the materials. So like if you got a delivery today and you have another mason jar and you want to make it, go for it. If you want to wait and do it in class on Thursday, that's fine too. But what I want to see from you guys for your assignment on doing your lava lamp, I would love for you to take just a really short video of your lava lamp in action. So like as you add those Alka-Seltzer tablets. Now, if you're feeling really creative, I would love for you to play a song in the background, just so it kind of, you know, anything that kind of comes to your mind as the lava lamp is going. Okay. Again, you know, steam is kind of throwing in that art with it. So I was kind of a dork and put my lava lamp to some music because again, it's purple. Now, a lot of you may not know this song. I'm going to be really impressed if you do, but you can watch my video. And my video is like 20 seconds long. Like it's not long at all, but let me play it. So if you can hear it, I had to laugh at it. So if you know Prince's Purple Rain song, because again, my lava lamp is purple and I was like, oh my gosh, it looks like purple rain. That's perfect. So again, for your assignment for this, I would love for you to be a little creative and to your video, play a song that comes to your mind as your lava lamp is going. Okay. Oh, you couldn't hear it. Dang it. Hold on. I got to fix that because you got to be able to hear it. I bet it has something to do with my audio. Let's do this. Real tech. Oh yeah, I bet you can hear it now. All right. Oh yeah, now you can. All right, hold on. Time out. Oh, come on. I mean, you know that's funny. So again, Purple Rain by Prince, because I looked at it and I thought purple and it kind of looks like it's raining. Fabulous. Okay. So you can access, if you want to see, again, it's here on this assignment. But when you make your lava lamp, like I said, I'd like for you to, play a song in the background, have a little fun with it. So again, I'm really sorry that your mason jar wasn't there. Life happens. It's part of it. It's not a big deal. So if you get your materials and you want to make it, go for it. If you want to wait and make it in class on Thursday, because we're going to do another project on Thursday, but we'll have class time on Thursday. We will make it work. It's not a big deal. Okay. Because I really want you guys to be able to keep your lava lamp. So like now my lava lamp is done. Well, if you want to power it again, you would just put in another Alka-Seltzer tablet and it'll keep going as long as that Alka-Seltzer tablet is there. Okay. So if you do make it, and you can go ahead and do the video, go for it. If not, wait until Thursday when you have your supplies and we'll do it then. Okay. We will also talk about the post-lab discussions on Thursday because I want you guys to have it, because there's a huge difference between watching me on a camera screen do it and you guys actually getting your hands dirty and you making it yourself. So I would much rather answer those questions after you guys have already done it. Okay. Does anyone have any questions? None. All right. So like I said, class is a little short today just because we didn't make it together, but it'll be fine. We'll get it taken care of on Thursday. Okay. All right. So that's all I have for you. Yes. So are you in Missouri, Genesis? You will be getting, Are you getting a new delivery or have you already gotten your delivery? Okay, I'll check on that. Oh, so you only have one total. Okay. All right. Let me think about that a little bit and I'll get back to you on that one. Okay. All right. Other than Genesis, does anyone else have any questions? Y'all good? Like I said, you'll be able to make it a little later this week. Okay. All right. So, you guys, I'm done with class. You can go ahead and go for the day. And I will see you Thursday, 1 o'clock. Have a great day. Okay. Bye y'all. See ya.